Okay, welcome to the first video lesson for pre-calculus at Speedway High School. This is going to cover the first half of section 1-1 in your pre-calculus textbook. So it's going to cover functions. It's a review of Algebra 2. So, first up is interval notation. Interval notation is extremely important in calculus, so as a pre-calculus student you need to be very familiar with interval notation. Okay? So when we're doing interval notation, what we're talking about is we're taking what we're used to, which is seen on this screen down at the bottom, these inequality notation, and we're turning it into an entirely different type of notation. So first off, when you have a greater than or a less than symbol, that endpoint is not included. However, if it's greater than equal to or less than equal to, that would be included. Okay? When you're looking at a number line, you're talking about values that are open circles. That is not included. Whereas if you're looking at an interval with a closed circle, that value is included. So open circle versus closed circle. So the first thing is just taking a inequality like the one seen here in example 1, A, B, and C, and writing them in interval notation. So here we're saying x is between -8 and 16, but notice -8 is not included in that. There's no line underneath that less than symbol. So when we write that, -8 is on the left end, but it is not included, which means that it is a parenthesis, whereas 16 is included, so it gets a square bracket. That notation tells us that 8 is open, 16 is closed. Okay? So when it's not included, we're using parentheses. When it is included, we're using square brackets. On letter B, we have x is less than 11. Notice that there is no left endpoint. Now what that really could say is that x is between -infinity and 11. -infinity and positive infinity always, repeat, always get regular parentheses when you write them in interval notation. Letter C is going to require even an additional symbol that we didn't have before, the or symbol. So here we have -infinity is less than or equal to x is less than or equal to -16, or 5 to x to infinity. That's what that's saying. So what we do is we write out two different intervals from -infinity to -16, and that is included. Actually, now that I look at it, there should not be a line here. Okay, and then we use the or symbol. Nope, that's the and symbol, sorry. The or symbol, and then we launch the other interval, which is 5 to infinity. Just a quick note, this is the symbol for union, which is the word or. This is the symbol for intersection, which is the word and. Okay, so next up, function is a relation where each input x has exactly one output y. In other words, when you're looking at a table, a mapping, or a list of ordered pairs, we have absolutely no x values repeating in the domain. Okay, you might remember the vertical line test. These would be our graphs that pass the vertical line test, and we will get to that on a later screen. So for now, what we're looking for here is, are these functions? Well, the first one is a yes, because we have no repeating x values. Okay, you can look right here. There are no x's repeated in the x column. That makes that relation a function. Okay, on B, this would be a vertical line test problem. So what we would do is we would grab a notebook or a calculator, something that we can use that has a nice vertical line to it, and we would slide that bad boy across the graph. Oh, looks like I'm deciding I'm going to slide the whole graph. Slide that across the graph, and you'll notice that that line only touches the graph of the function at one point at any time. Since it doesn't touch it twice anywhere, this does in fact pass the vertical line test. So we would say yes, because this passes the vertical line test. Okay. Function notation. Keep in mind that when we have an equation, we generally have y equals something along the lines of, I don't know, 3x plus 4 or 3x squared plus 4x plus 3. You know, this is equation notation, okay? But in higher math, we no longer use y. We use function notation to state that a function of x is 3x squared plus 4x plus 3. So here we're going to work on plugging these values into g of x. If we want to find g of 6, what we are doing is replacing the x in g of x with that 6. So that'd be 6 squared plus 8 times 6 minus 24, which we would then reduce the entire right side of that expression, completely ignoring the 6 on the left. 6 squared is 36, 8 times 6 is 48, minus 24. So g of 6 would be, what is that, 60. Done. On the second one, we can plug in expressions. They don't have to be values. So there what we're doing is we're plugging negative 4x in for x, which would be negative 4x quantity squared plus 8 times negative 4x minus 24. And then we simplify. So g of negative 4x equals 16x squared minus 32x minus 24. With no additional like terms, that is as good as that's going to get. Finally, and I'm going to have to move this one, okay? So I'm going to go ahead and cut this thing up so that we can see it. I'm going to move this down here. G of 2a plus 3, same idea. We're going to plug 2a plus 3 in for x. So that would be 2a plus 3 quantity squared plus 8 times 2a plus 3 minus 24. We need to expand that all the way out and then combine like terms. Please don't be that guy that tells me that 2a plus 3 quantity squared is equal to 4a squared plus 9. That is absolutely wrong. You need to FOIL. This is 2a plus 3 times 2a plus 3. You have to FOIL that out. So that would be 4a squared plus 12a plus 9, because you'd have a 6a and a 6a for the outside and inside terms. So this is 4a squared plus 12a plus 9. Then we would distribute the 8, giving us 16a plus 24, and we have the minus 24. That's g of 2a plus 3. So one last step would be to combine like terms. We would have 4a squared, because it's the only a squared term. We'd add the 12a and the 16a together to be 28a. And then we would add the 9, the 24, and the negative 24, which is 9. That is it for the first section. Thank you for your time and attention.